It didn't even start yet.
All right. Selena,
What?
every time I'm looking right now, I'm seeing your head that way. So
Just look, they were talking.
I'm here.
They had
Look at
my
me.
attention.
Selena wasn't.
So now they're talking too much.
All right, here we go. You guys, you are going to do this. Today you will verify, which basically means you're going to prove trig identities by transforming one side into the form of the other side of the equation. So you're going to show me the left side truly does equal the right side of an equation. And then it says I can use trig identities to simplify an expression, which is exactly the same thing, except the equal sign is gone. Okay? Now how much of that made sense?
None of it.
And probably none of it. Come back later and read it, and you'll probably go, oh, now I know what he's talking about. Okay. This was given to you in chapter 13, actually 13:8. The reciprocal identities were, presented to you, and we used them. And we didn't use them much, but we used them enough where we probably learned them. Cosecant of theta is equal to 1 over what? Sine. Now, if you did look at these last chapter, this will make a lot more sense now. Cosecant is the reciprocal of sine, 1 over sine. Secant and cosine are reciprocals of each other. Secant's 1 over cosine, tangent's 1 over cotangent. And then, of course, they did the bottom ones down here. I guess these two kind of go together, don't they?
Yeah.
Yeah, these two go together, these two go together, and these two go together, okay? Now, these are all called reciprocal functions. You will be doing this today. You might see this, but instead of seeing this, you're going to write what? That. So when you see this, you write that. When you see 1 over cosecant, you write what? Sine. That's what you're doing today. Okay. Then they go into this tangent identity and this cotangent identity. These two, I do need to prove these to you. I don't want to just tell you what they are, even though you see it. I don't want to tell you, I want to show you. So come back here on the whiteboard now. Answer these questions. Whoa, sorry. This wasn't supposed to be here. Okay, looking at this triangle from chapter 13. Does this ring a bell?
Yep.
Theta's here. What's the sine of theta?
Wow.
Y over r. Ooh, that doesn't show very well. Y over r. What's cosine of theta?
X over R.
X over r. What's tangent of theta?
Y over X.
Y over x. Okay, so does this ring a bell? Okay, now move this way. Let's do it again, except your radius, your r value, is now, what if it's what?
1.
What if it's 1? What's sine of theta now?
Y over 1.
Y
Over
Over
1.
1.
over 1. But what's y over 1? Y.
1.
This is fading on me. What's cosine?
X.
X over,
1.
which is
X.
x. Now, by me writing that, here's what I was hoping you'd understand now. Gotta get it to you now. Forget. There you go. Here's what I'm trying to do now. If you know y is equal to sine of theta, look what I can do. I can get rid of this y and put what? Sine of theta, right? Okay, and see that x? That x is equal to what?
Cosine.
So I can put cosine here now, right?
Yeah.
Okay, well now that I wrote that, can you tell me tangent?
Yeah.
It's opposite
Sine.
over adjacent.
Sine.
Sine over what?
Cosine.
Cosine. Sine of theta divided by cosine of theta equals tangent of theta.
That's what it says.
Okay, now that is what it says right there, but do you trust that?
No.
You trust me? Okay.
Yeah.
Hey, guys, when I was taking math, when I was high school, college, I looked at it, but I didn't know why. So here's what I did. I said, well, if this is true, then tangent of 45 degrees should equal what?
Sine of theta over cosine.
Sine of what?
45.
45 degrees over what?
Cosine.
Cosine of 45, right?
Yeah.
Isn't this what it says?
Yeah.
Okay, but I know this answer. Do you know what is tangent of 45? Let me draw you a 45, ready? 1, 1, square root of 2. There's your 45. What's tangent of 45?
1 over.
Yeah, it's y over x. It's 1 over 1. Answer's what? 1. So that over that should also be what?
1.
Take your calculator. Do sine of 45 divided by cosine of 45. See if it works. They're telling you it works. Don't just trust it, actually do it. What is your calculator telling you about
1.
Does it say 1?
Yep.
How?
It says one.
How?
It says 1.
What?
Nick, put it.
No, mine just says syntax error.
Well, you typed it in wrong. I think you did. Okay. So anyways, it does work. Now, here's the deal. The tangent identity is sine over cosine. The cotangent would be what? Cotangent
Sine.
is the reciprocal of tangent. So you'd flip this and get what?
Cosine over sine.
Cosine over sine. That's exactly right. Okay. So these are your functions on page 1. So you must use those functions to fill in the rest of this. All right, you guys ready? What is cosine of 58 degrees if they write 1 over something? Cosine of 58 is the same as 1 over
R.
sine of 58. No, sorry, that's not right. Cosine is the reciprocal of what? Secant. Secant of 58. Are you guys looking right about here?
Yeah.
Isn't that where you should have been looking?
Yeah.
Okay. All right, let's try this one. Cotangent of 129 is the same as something over sine of 129.
Cos. Cosine.
If you have cotangent right there, there's cotangent. Cosine over sine. So you'd say what? Cosine of
129.
129. Can I tell you what other students have asked me? Other students have said, well, why can't I write this? Cotangent is just the reciprocal of which one?
10.
Tangent. Why couldn't I have wrote that?
10.
And the answer is, you can write that, except they put sine on the bottom. And when they put sine on the bottom, it was this identity, right? Okay? So you kind of got to look at what they put there for you. Tangent of pi over 4 is the same as 1 over.
Cotangent of
Hot.
over 4.
Yeah, it's right there, isn't it? 1 over cotangent of
5.
pi over 4. Okay. All right. They're just trying to get you guys to look at your blue sheet and try to pick out the right one. All right? Okay, here's where we really start. You are going to verify. You're going to prove the left side is really equal to the right side. Okay? So to me, the left side is a very complicated looking expression. But I need to prove that it's equal to what?
1.
1. So you know what's really nice about this? They actually give you the answer. The answer is what? 1. So you're looking for this answer. So you want all of this to equal 1. So let's prove it. But I'm going to give you a hint. And here's my hint, and you should write this down. I would like everybody, when you do these problems, would you please convert all trig functions into sine of theta or cosine of theta. If you do this, your day will be so much better, okay? So guys, look at this. This says what? Sine of theta. That's what I want. Everything should be what? Sine or cosine. Okay, what about this? Cotangent. I don't want cotangent. So we're going to write sine of theta, right? Times what? Cosine over sine. Times secant. Don't want secant. 1 over cosine. So now everything is in either sine or cosine, and I am asking, or this problem is asking us to take this number sine, sine over 1, times cosine over sine, times 1 over cosine, and multiply 3 fractions. Now please tell me, when you multiplied fractions back in probably 5th grade, did you do this? 2/5 times 5/11. When you multiplied, what'd you do? Find the common denominator. Do you need common denominators when you multiply? No common denominator needed. Wasn't multiplication just this? That times that, that times that?
Yeah.
But did you do that?
No.
Or,
You can take out the fives.
yeah, the 5s are in common. Look, 5 on top, 5 on the bottom, those are the same number. Anything in common can be canceled out. 5 goes into 5 once. So what's the answer? 2 11s, right? That's it. That's all you did in 5th grade, right? It's no different now. Go back to algebra 2 and just do the same thing. Here we go. Okay, ready? Sine times cosine times 1, 1 times sine times cosine. Well, cancel. What are you going to cancel?
Sine.
Sine with a sine, right? And that's 1, 1. What else?
Cosine.
Cosine with a cosine. That's 1, 1. Cosine goes into cosine once. Sine goes into sine once. So now all you have on top is 1 times 1 times 1. On the bottom, 1 times 1 times 1. You get 1. You get 1. Over 1, which is? Is that what I was supposed to get?
Yes.
Yes. I just proved the left side is equal to the right side. Do the next one. Take sine, divide it by cosecant, and prove to me it's sine squared. Out of these two functions, which one do you not like?
The bottom.
The bottom one. Sine is good. Just leave it sine. Sine of theta divided by what? Look at your identities. Look at your reciprocal identities.
Sine.
Cosecant's the same as what? 1 over sine. Okay. Here's what you're being asked to do. Take sine and divide it by 1 over sine. Now how do you take a number and divide by a fraction?
Multiply the reciprocal.
Okay, what is it that you multiply by the reciprocal? The top. The numerator sine of theta gets multiplied by what? Yeah, the reciprocal of the denominator. What's the reciprocal? Sine of theta over 1. Well, guess what? You have sine of theta over 1 times sine of theta over 1. What's that?
Sine squared.
Sine squared, right. So guys, oh, by the way, do not write it like this. Don't go like this. Because now it looks like you're doing what? You're squaring the angle. You don't want to square the angle. Just square the answer to it. So go like this. This is how they do it in trig. They write 2 right there. They do not put the 2 above the theta. So sine squared. Okay, did I prove it?
Yes.
No.
Okay, here's the deal. When you take a number, divide by a fraction, don't do it. Take the numerator times the reciprocal. Got it? Here we go. Prove to me cosecant divided by secant is cotangent. Go. What is cosecant?
1 over sine.
1 over sine. Okay, gotcha. Okay. What is secant?
1
over cos.
1 over cosine. Gotcha. Oh, you know what? This kind of looks like the previous problem. It's just the numerator divided by the denominator. Well, what's the numerator? 1 over sine times the reciprocal. What's the reciprocal? Cosine of theta over 1. Multiply two fractions. Simple. Top, bottom times bottom. What do you get? Cosine of theta
Sine.
over what?
Sine theta.
Sine of theta. Okay. Oh, guess what? Cosine over sine is just what?
Cotangent.
Isn't it just cotangent? Keep staring at your blue sheet. Your blue sheet says it right there. So this is cotangent of theta. We got it. You okay? You are proving the left side, that looks very complicated by the way, is really, really equal to the right side. The nice thing is on this page, on the first page of your homework today, they always give you what? They always give you the answer. The answer is cotangent. Prove it. So guess what happens on the second page?
You don't get
You don't get the answer. You just get this. This is all you get on the second page. You just get this. You don't get to see this. So you have to do all this and prove to me it's cotangent. And you have to come up with that on your own. Okay, let's go to the second page. But the second page, now they throw more identities at you, and here they are. These are called the what identities?
No.
Pythagorean identity. Doesn't that sound like the Pythagorean theorem?
Yeah.
Yeah, it is. Now watch this. Let me prove it to you. Okay? There's your right triangle. There is your hypotenuse, right? Here, I'll draw this x-axis. I'll draw the y-axis. Okay. This is called the x value. This is the y value. But we just called it what instead now? This is now cosine of theta. This one's what? Sine of theta. Okay, if you think Pythagorean theorem, that's right triangle stuff, right? Tell me, what's the Pythagorean theorem say?
A squared plus b squared equals c
But
squared.
what's a squared plus b squared? What's that? What?
Sine squared.
Yeah, it's leg squared plus leg squared equals hypotenuse squared. Well, what's the leg? Cosine squared, right? Plus
Sine.
sine squared equals what?
C.
Equals hypotenuse squared. 1 times 1. Boom. We just figured out the first Pythagorean trig identity. What is cosine squared plus sine squared? It's always what?
1.
It's always 1. Okay, if you don't get what I'm saying, what I'm trying to tell you is this. If I did this, cosine of 50 degrees squared plus sine of 50 degrees squared, guess what I'd get?
1.
I'd get 1 every time. It's like, hey, if I keep that theta the same, I'll always get 1. That's what this is telling you. Okay, now, there's 2 more, isn't there?
Yep.
Okay, well, here's the deal. There are 2 more, but I'm just going to show you how they came up with them. They did this. What they did is they looked at this equation and they went like this. What if, just what if, I took this Pythagorean theorem, this trig identity, and I just divided it by cosine of theta squared. What if I did that? Well, then I'd have to do it here, and I'd have to do it here, right? Okay, so now would you just tell me what is cosine squared divided by cosine squared?
1.
Isn't that just 1? So this is, they get a 1 plus
Sine squared.
sine squared over cosine squared.
Just 1.
Squared.
Is what?
Tangent
Tangent squared,
squared.
yep. Equals 1 over cosine squared. Well, that's a reciprocal function. Cosine's a reciprocal, which one? Secant. So that would be what? Secant squared. Hey, guess what? Here's the second one. Or maybe it's the third one on your notes. I'm not sure. So the first one's right here, right? The second one's right here, and now to get the third one, you know what they did? They didn't divide by cosine squared, they divided by, what do you think? Nobody has a guess? Sine squared. So if you divide by sine squared, and sine squared, what would be the new ones? Anybody want to tell me what cosine over sine squared is? That's cotangent. So that's cotangent squared plus, what's that? 1 equals, what's 1 over sine squared? Cosecant squared, yep. Okay, so this becomes the final one, right? Are they all in your notes? Yeah, they're all up there. Are they all on the blue worksheet? Yeah, they are. Okay, so then that's where they came up with them. So they're all right here, here, and here. Now you have to be able to manipulate them and change them back and forth. So guys, here's what they want you to do. For number 9, they want you to take secant squared minus 1 and come up with an answer. Where do you see secant squared? Boom, boom, or boom. Second one? Okay, me too. Tell me what secant squared minus 1 is equal to.
Tangent squared.
Tangent squared? Cole says tangent squared. Cole, how'd you get that?
I just kind of flipped them around off the second one.
Off the second one. He flips them around. He tries to get this look. How does he get secant squared minus 1? Did you minus 1 in your head?
See.
Yeah? So he gets rid of this 1 minus 1, and now he gets what? He gets tangent squared equals secant squared minus 1. Is he right?
Yeah.
Yeah, he's right. Are you watching? Are you with me? What happened to her?
Fleeing.
Where's she at?
Is the answer 0?
No, the answer is tangent squared. Okay? Alright. What about this one? What do you think cosecant squared minus cotangent squared is equal to? First of all, which one are you looking at?
-1.
Are you looking at the
Third one.
Third? Okay. So you want this look, right? So cosecant squared is right there. Move that over, right, guys? Wouldn't that just be what?
1.
Minus cotangent squared minus cotangent squared.
1.
What do you think it is, Brock?
1.
He says 1. Do you agree with Brock?
Sweet
Yeah.
work.
Cosecant squared minus cotangent squared is 1. He's right. Good? All right. Now, why is the second page harder than the first page?
They don't get the answer.
They never tell you the answer. They expect you to come up with the answer right now. So you know how it says cosecant squared times tangent squared?
Yeah.
I said that wrong. I said that totally wrong. Cosecant theta times tangent theta. They want you to come up with the answer. Go. I'll give you 30 seconds. Anybody got it? Some people work ahead, I know that, so I'm just wondering if anybody got it. Just point at it if I come by and you haven't done it. Okay, is tangent of theta really 1? Oh, remember my hint.
Yeah.
Hey guys, remember my hint? My hint is change everything to what?
Sine or
Cosine. If you guys are changing things to secant and cotangent and all that, that's kind of messy. That is just messy. Well, this is not a clean look. You are right that this is this. But I want everything to be sine or cosine. Get tangent out of it. Okay, here we go. I'm not sure if you guys are quite with me on this tangent and cosine thing. I need everything to be sine and cosine. So what is this?
1 over
1 over
sine.
sine. Okay, 1 over sine. Okay, times, what is tangent when it comes to sine and
Sine over
cosine?
cosine.
Sine over what?
Cosine.
Cosine.
Say cos.
We're small, but
Alright, but
Oh, cosine.
Okay,
it's
All right.
cosine. Agree with the cost.
now,
And set the actual.
fraction times a fraction, simple, right?
simple.
If we can cancel, we'll cancel.
Yep,
Can we?
yep.
What?
Sine.
Sine goes into sine once, sine goes into
Do
sine
you have to flip
Once.
the second one or no?
only when it's division. So what does this say to you?
Allison.
1 times 1.
But didn't you put them over each other?
Well, Nick, the only time I multiplied by reciprocals was when it was
1
division.
over cos.
1 over
I
cosine.
said- Never mind.
Okay, but wait a minute. That is not a clean look. A clean look would just be one trig function, not 1 over a trig function. So yeah, what is it?
What is SCC?
Secant. 1 over cosine is the same as just secant. Secant is much cleaner than 1 over cosine. So this becomes our answer.
Oh, yeah.
What is SCC?
Secant, I've said it. Secant,
It's called
secant.
secant.
I've been saying it for 2 chapters now.
Come on.
All right, go. Next one.
Sessions and conference.
No, I have SCC on my thing.
SEC. SEC.
Don't you?
S-E-C.
Mine's
Where do you see
mine's
that?
Okay, Ty, Ty.
Yeah, it says
Ty,
SCC.
the question was good. That we're done. Don't talk to them.
I know what he was asking.
Don't talk to them.
I was just so lost. That's one of my-
Michaela, did you get an answer?
Yeah,
What is it?
I got cosine.
Just secant?
I got 1 over sine.
Okay, so Michaela, you said that's your answer, right? No? What'd you say?
Cosecant.
1 over COS.
Wait, okay, time out. Let's try this again. If your name's Michaela, you can talk. Don't talk. Michaela, what's your answer?
Cosecant.
Cosecant, my fault.
So good.
Okay. So she says the answer is cosecant of theta. Okay, this 1 over, or sorry, secant is just 1 over what?
Sine.
Theta.
No, cosine.
It's 1 over cosine.
1 over cosine theta.
Times
Cosine over sine.
cosine over
One
sine.
over sine.
Okay,
And then you
Cross out those 2 coses.
now,
It's 1 over sine.
It's 1 over sine to theta.
okay, hang on here.
which is sine.
Selena, come up here. Sit where you were always.
You actually have to say that.
Just come up here.
No.
What am I doing?
You're not doing anything.
Exactly.
I haven't heard Selena talk this whole period. It's been
Hey,
cool.
come on, Leah.
That's hilarious.
Okay. Now, multiplying 2 fractions, like we've done them before, cancel, 1 over 1. And again, it's just top times top, 1 over the bottom 2, sine of theta. Did Michaela get that right?
Yes.
Yes, she did. Okay,
Mr. Painter?
Yeah.
Do you have to say that 1 above sine right there?
do I have to see this?
You have to say the 1. Do you have to say it?
Do you have to say?
Nick's trying to say you can just say sine theta, and that's the answer.
No, sine theta is not the answer. It's 1 over. It's 1 over sine. 1 over sine is cosecant. Okay,
So
Sine
what if
over
we
1
left
is
it in
just
that?
sine over 1 is just
What
sine.
if we left it over?
What if you did what?
Left it as
Said
one
the
sine
reciprocal of
Okay,
that.
hey, Nick, Nick. I'll answer the questions, okay? You have to say 1 over sine or else it's wrong. And then 1 over sine, you have to know that's cosecant.
But what if you don't put it as that?
What are you saying you're gonna do then?
Like say like if we left it like that on a quiz.
Oh, left it like this?
Yeah,
Oh, okay, first of all, when you did this to this, that's 1 point.
yeah.
This to this, that'd be your second point. If you ignore this, you lost 1 out of 3.
Oh.
I mean, I'm just basically giving you 1 point, 1 point, 1
Okay.
point. Until you get to the end, if you quit too early, you lose points.
Alright.
Okay? All right, go for the next one right here. 30 seconds. Let's see what you can do. Yes. I know, but here's the deal. Secant is theta. It's 1 over cosine. And it says times. It says times cotangent. So you gotta say times. Don't turn it into contingent unless it says that. So you're like changing the problem, and you can't do that. Okay? All right. Cosine squared times secant theta times cosecant theta. All right. Now, one of the functions is good. 2 of them are bad. Which one's good?
The second and third ones are easy.
Those are the bad ones.
The good
Okay,
one.
the good one is simply cosine. Don't change cosine. So cosine squared times, not change secant,
1 over
One over
cos, and then 1 over sine. That's what I thought it was.
times 1 over sine. Okay. Now that's probably where you want to start, and then just look at it. It's a number over 1 times 1 over cosine times 1 over sine. What you need to realize is cosine squared is really just cosine of theta times what? Cosine of theta. So try to remember. I mean, you don't have to write that, just remember that. And now you got a cosine times 1, 1. And over a cosine sine. What are you gonna do?
You can get rid of the cos on the bottom, and then
Okay? 1
Another
cosine
one.
would cancel
you
with
can get
1 cosine.
you can get rid of that too.
So now this cosine times 1 times 1. Isn't that just cosine?
Cos over sine. Yeah, that's what I'd say.
1 times, this is a 1 now. 1 times 1 times sine, sine.
Yeah, that's what I'd say right
Okay.
there.
Cosine over sine is cotangent. See, and this is the bad part. They never told you it was cotangent. You had to come up with that trig function. So these 3 functions multiplied give us cotangent. Good?
Yep.
Okay. Take a look.
Yeah, we can cancel each other out and do 1.
Now I gotta just tell you something right now. If you ever see this, cotangent squared with a 1. If there's a 1 in a trig function squared, I'm thinking Pythagorean. I'm thinking Pythagoreans because I see the 1 in the cotangent. So you know where I'm gonna go? I'm gonna go up to the top. Where's cotangent? Right here. Right?
Maybe it's just 1.
So now, if all I have is this, I have 1 plus cotangent squared. What is 1 plus cotangent squared?
Cosecant squared.
It's cosecant squared. So, could I just write this, cross this out, and go what? Cosecant squared. Cosecant squared over
Is the answer to this 1?
cotangent squared?
No, it's not.
I don't know. I can't remember.
It should be 1, because
Can't
look
you
at
just
it, it's
cancel
like,
the cot?
yeah, you could just cancel out that.
Oh, gotcha.
You
Yeah,
just cancel
that's
the
what I
top.
asked, but whether.
Okay, but wait. It's not. Listen, you can only do this. I know what you guys want to do. You want to do this and this. This can only be done if you have what?
Like times.
Multiplication. You don't have multiplication. You can't do that. Okay? So, sorry. Good try. It's not it. All right. Now, remember, this Cosecant is 1 over what?
1 over
1 over sine.
Sine squared.
squared.
Well, if that's cosecant squared, it's going to be sine squared.
Okay.
Cotangent's what?
Why?
1 over 10.
No. Well, you could go to tangent if you wanted, but I say go to sine and
Cos
cosine.
over sine.
It's going to be cosine squared over sine squared. I want to keep everything in sine and cosine. Okay, so here's what it says to me. 1 over sine squared divided by cosine squared over sine squared. How do you treat division?
Can we just
Sine.
Yeah, you don't. You don't.
Done.
You don't do it. You take the numerator, which was 1 over what? Sine squared
Theta.
Times the reciprocal.
So
Sine
sine
squared.
Sine squared what?
theta times 1.
Over cosine squared theta. So what do you notice about the sine squares?
They can cancel out.
Okay.
You have yourself
And now it becomes 1 over what?
cos squared 0.
Sine.
Okay.
Line 0.
Which,
Also known as theta.
you guys, anytime you see 1 over a trig function, you should go back to the cleaner side. That's just secant, isn't it? Secant squared. That is the cleanest look we can have. 1 over cosecant squared is just,
secant squared.
Yeah, because
it is secant squared, isn't it?
Yeah.
Yeah.
I have the square there. Okay. And that is a big mess, but yes, that's how you do it. Okay. This one on the far left corner, the bottom left, is probably,
The hardest.
it might be the hardest, I think. But let's just kind of go, let's go slow with this, ready? Where's the good and where's the bad?
The good
That
is
first
the
one, what's,
cosine and
you
the
can't
sine.
do 1 over sec.
Cosine's good. Cotangent, not so good. What is cotangent?
1 over 10.
1 over sec. Oh, cot.
Okay, guys, keep it sine.
Cos over sine.
Yep. Okay. Then plus, right? Okay, is there anybody that I confused?
No.
No?
Isaac
Okay.
might be.
I just turned cotangent into cosine over sine. Okay, now, here's the deal. That's multiplication followed by addition, right? What do you do first?
Probably get rid of those 2
Cosine
signs.
over one.
You can cancel out those signs if you wanted to. That's just me. I probably
Right.
Okay, guys, let me try this again. Okay, Ty, wait for my question. This is multiplication. This is addition. What's first?
The
Multiplication. Guys, order of operations always say multiply first, add less. So let's multiply these 2 fractions. Cosine times cosine is,
Cosine squared.
okay, over
One.
sine. Okay, that, I don't think that was the hard part.
It's pretty easy to
The
use.
hardest part will be this. Now they want you to take a fraction plus a fraction. And back in 5th grade, your 5th grade teacher probably said, when you add 2 fractions, you must have
Common.
common denominators. Okay. So your denominator right now is sine and 1. Now, what if I would have given you something like this? 2/5 plus 7 over 1. What's the common denominator in this one? What does 1 and 5 both go into? 5. So guys, when you have a 1 down here, 1 goes into 5. Well, same thing here. 1 goes into sine theta.
Instead of the sine over theta.
Yeah, so what's your common denominator?
Sine.
Sine. So put sine of theta, put sine of theta. This fraction does not have to change. It's over sine already, just leave it. Good? This fraction, sine over 1, needs to change to something over sine. Well, how do you get rid of,
Cos squared theta over sine theta.
Opposite is
how do you get 1 to become sine? Multiply by what? Sine. Sine of theta times 1 is sine of theta. Do the same on top. Sine of theta times sine of theta.
sine squared.
Sine of theta what? Squared. Now you have two fractions with common denominators. Well, oh, this would be what then on the bottom? When you add two fractions, the denominator never changes. What's the top going to be?
Cos.
Cosine squared plus sine squared over sine. But do you recognize the top as one of the Pythagoreans?
Yeah, it's a 1.
It's just one. Sine squared plus cosine squared is just 1 over sine squared.
1 over sine. We
Cosecant.
could clean that up a bit, make it cosecant if you wanted.
Can't.
Squared.
Oh.
No, there's no square now,
No.
because this just makes 1 on top. So there it is. It's cosecant.
Okay.
That was kind of difficult if you ask me, because you had to multiply two fractions, then you had to add two fractions. Okay, now we got to hustle back and do this one right there. Okay? I might have to, with the time, kind of almost guide you through this. Sorry. I'd like you to do it yourself, but.
As if I'm teaching this.
Okay, now, you guys, you got tangent squared, right? Minus secant squared. Okay, watch this. Tangent squared, secant squared almost sounds like one of the Pythagoreans, right?
Almost something.
Tangent squared, secant squared, it's all there, right? Here's what I would do if I were you. When I see that, I would go like this. I would go tangent squared. If I just want tangent to be all by itself, tell me what tangent squared equals. Move the 1 over here.
Secant squared.
Secant
minus
squared.
1.
What?
Minus 1.
Okay, now look what you just told me. You told me tangent squared is secant squared minus 1, right?
Yeah.
Take secant squared minus 1 and substitute it in for tangent squared. So what is tangent squared?
Secant.
Secant squared minus 1, isn't it? Minus
It's arithmetic.
secant squared, right? You see what I just did? Guys, I went to your Pythagorean theorem up there, and I solved it for tangent squared, and I wrote this. Secant squared minus 1 minus secant squared. What do you think is going to happen here?
0.
No,
See this goes.
not 0.
Secants are gonna cancel.
The secants are going to cancel.
Carlos, flip it.
What's the answer?
-1.
You just
-2.
minus 1 from that.
Negative 1 is the answer.
Oh!
Oh, got it. We got it.
Oh!
You got me.
Thank you.
You have it.
So you
Alright.
all Victoria.
What shape? What shape? What shape?
And once she just looked over to the conversation.
Anybody want this?
I said, be quiet. I wasn't talking.
Salinas, you were talking.
Victoria, I'll punch you in your mouth. Shut up.
We both punch you in your mouth.
Alright, anybody else? Kayla, here's yours when you come. Di, Elsa, Brittany, what do you think? You got 'em?
Yeah.
You already got one?
Really, Isaac, my name on the board.
And Elsa.
Donkey. Yeah.
You need one?
I already got one.
Got one. Josh, you got one? Okay.